these forces pushes the car at various angles. And one, you have to determine the resultant. The resultant force, calculate the magnitude and direction of the resultant force. And I added that you find the magnitude and direction of the equilibrant. Okay. So having learned resolution of forces, we resolve each one into vertical and then horizontal components. And it is always easier when you use the angle given. It is always easier when you use the angle given. And don't forget, for bearings, angular measurement. For bearings and vectors, angular measurement is always taken from the north. So F1 X would be 22 sine 30. If you want to use the other one, then don't forget when you draw the north within the Cartesian plane, if this is 30, this becomes 60. So if you want to use the other angle which complements this, then you must know how to go about it. In this, if you want to use the angle it makes with the x or the east, then it becomes 22 cos 60 and 22 sine 60. Okay, but it is always easier using the angle given. So F1 y is also 22 cos 30. Then you resolve F2. F2, F1x, F2x is 315 sine 90 degrees. And then F2y, 315 cos 90. If you want to use the other angle, this is how you must go about this. This is 90 from the north. Then the vector or the force F2 lies on the x-axis. And this is 315. So if it is 90 degrees from the y or the north, the question is that what angle does this make with the x-axis? What angle does this make with the x-axis or the east? Yes. Yes. What angle does F2 makes with the x-axis or the east? Elizabeth. Lizzie, are you there? Hello, Benedicta and Co. What angle does the force F2 makes with the x-axis? Anybody? Just to try, Yasmin. Mamiya. It makes an angle of 0 degree. The angle it makes with the x-axis is 0. F2 lies on it. Lies on the x-axis. So the angle it makes with the x-axis is 0. So if you want to use the angle this makes with the x-axis, then this must be equal to 315 cos. Don't forget, if you want to use the angle it makes with the x, then the other must be cos sine. So cos 0, and this is also 315 sine 0. And you realize that the value will be the same. Cos 0 is 1. Sine 0, okay, is 0. Please, are you okay? Are you okay here? Hey, are you people there?
Yes, please.
Let me hear your voices, please. Okay, so let's resolve F3. F3x is equal to 240 sine 120 degree. Then the y, F3y, is 240 cos 120 degree. If you want to use the angle, the other angle, it makes with the x. This is 120. So 90 plus 30 would usher us into the fourth quadrant, or would give us 120. So this angle it makes with the x is 30. So if you want to use this, then fx becomes 240 cos 30 degrees and then 240 sine 30 degrees. But the vertical component, which is the y, is negative. Oh, sorry. It's this is sine. Yes, it will be negative. It will be negative. So that will be the components of each one of them. Okay. So let's find the actual values and then quickly use that to find our resultant force and then the equilibrant. So F1 sine 30 is half. So this is 11. Cos 30 is root 3 on 2. So 11 root of 3. Then sine 90. Sine 90 is 1. So this is equal to 315. Cos 90, 0. Then sine 120 is equal to sine 60, which is root 3 on 2. So 120 root 3. Then cos 120 is equal to minus of cos 60. So this is half, negative half. So we have minus 120. Okay. So let's look at for summation f of x. Our summation f of x becomes 11 plus 315 plus 120 roots 3. Please sum everything up for me. 11 plus 315 plus 120 root 3. Elizabeth, Yasmin, and Co. I'm waiting for you. Paulette. What's the results? Joel and Co. You are also there.
523.8.
500 and
23.8.
oh, I had 533.8. Oh, so
Yes, please.
Rachel, okay. .85 Newton. Then let's look for summation of Fy. So here we have 11 root 3 plus 0 minus 120. So check this out for me. Yes, Colette and co.
Minus
You said -100.
100.5.
Okay. So minus 100.95 Newton. So we want the resultant. Now, because you also need the direction, you must draw. Draw. This is your vertical axis, horizontal axis. Summation f of x is positive, meaning summation f of x will be along the positive x-axis. And this is 533.85. Then summation f of y is negative. And please, here I saw that some of you were repeating minus 100, blah, blah, blah. Please, why are we directing it along the negative y-axis? We are doing this because this value is negative. If it is positive, it will be along the positive y-axis. So by directing it along the negative takes care of minus. So that must not be repeated. So summation f of y, which is 100.95. When you have two vectors, one acting this way and downwards, the resultant will be along the diagonal. So by equal vectors, you have the resultant r acting along the diagonal like this. And because this is perpendicular to this, this equal vector would also be perpendicular to this. Don't forget this summation fy, which is 100.95. So by using Pythagoras theorem, you have r squared being equal to summation f of x squared plus summation f of y squared. Put in your values. You have 533.85 squared plus 100.95 squared. Therefore, r will be the square root of everything. The rest is just calculator's work. You shouldn't get this part wrong because you'll be using the calculator to find your value of r. Okay. So there is no way you must get this part wrong. So the resultant is 543. 543.3 Newton. That is the resultant. Now the direction of the resultant. Once you have, we are talking about the angle it makes with the x-axis or the summation of x. Find that. And then when you finish, you add that this value of the angle to 90. This is because we are always taking our angular measurement from the north. So when you get this acute angle, you then add to 90 to give you the direction of the resultant as measured from the reference point, which is the north. Okay, so tan of theta is equal to summation f of y over summation f of x. And some of you could attest to the fact that a lot of you had it difficult when you brought the negative. Divided by 533.85. So that is also calculator's work. Divide 100 by 533.85. And this is it. When you finish, take the tan inverse of your answer and you are good to go. And you have approximately 11. Theta is approximately 11 degrees. Therefore, the angle from the north will be 90 plus 11. 90 plus 11, which is 101. So the direction is of the resultant is 101 degrees from the north. Even if you don't write from the north, everybody sees it because our angular measurement is always taken from the north. That's it. Now, the equilibrant. Can I adjust the screen, the camera? Can I adjust it?
Yes, please.
The equilibrant. The equilibrant has the same magnitude as the resultant. However, its direction is opposite to the resultant. So once you found the magnitude of the resultant, it is equal to the magnitude of the equilibrant. What we need is just the direction. So the equilibrant must act in the opposite direction. If this is 11, this is also 11. Okay. Our equilibrant will be, if this is 11, 90 minus 11. 90 minus 11 is 79. So we can say that the direction of the equilibrant is 79 degrees, okay, in an anti-clockwise direction, meaning 79 degrees, okay, and in an anti-clockwise direction from the north, meaning when we measure the angle this way, okay, or if this is 11, this is from here to here is 270. So 270 plus 11 would also be 281 or 281 degrees. Okay. The moment you write 281, in fact, we all know it must be a clockwise direction, or you can specify. So the direction can be 79 degrees clockwise from the north, or 281 degrees from the north. This is the direction of the equilibrant, but its magnitude is the same as the resultant. Please, any question? Any question? So this simple. It's a simple question. I'm going to forward a question to the platform. I want you to think, try and then solve it within maybe 10 minutes time. Then I come in and I'm uploading the question right away. Okay, question is sent. Please, is it received?
Yes, please.
Okay, so we have 1, 2, 3, 4, 5 forces. We have 5 forces. 15 Newton acting at 60 degrees to the x-axis or the east. Then 19 Newton acting at 0 degrees to the x or 90 to the y. Then we have 22 Newton acting at 180 degrees from the north. Then we have 11 Newton, okay, acting at 240 degrees from the north. Then lastly, we have 16 Newton. And 16 Newton is acting, Leonard. So you are to look for the resultant force and then the direction. You are looking for the resultant force and then the direction of the resultant. So start well. I'll come to you in 10 minutes time to see what you have been. So start by resolving each one into components. Okay. When you finish, sum all the components up and I'll come back to you. It's 4:24, 10 minutes. So 4:34, I'll come to you to see what you've been able to do. Please, any question? If you don't have any question, start work and make me proud. I'll come to you. Hello, our time is up. So, in order not to waste time, let's go through the resolution of each one of them. So let's take the 15 Newton. We are moving in clockwise. So if we take, let me draw a table. For the forces. Then we look at, so this is the forces, F, then Fx, and then Fy. The first force, let's use the 15 Newton. So 15.0 Newton. Okay, the Newton has been taken care of. So 15.0. Then we have 19.0 force, followed by 22, followed by 11. Then lastly, we have 16.0 Newton. The x component of this, okay, of 15 would be 15 cos 60. And because cos 60 is half, this will be 7.5. Then the y component of the same force is 15 sine 60. Please, what is 15 sine 60? 7.5 times root 3. Help me calculate 7.5 times root 3. Yes, what is 7.5 times root 3?
12.99.
12.99.
Good. So we have 12 points. 9. Then 19. 19 has only a horizontal component and no vertical component. The horizontal component is 19.0. The vertical component is 0. If you want to use components, then it makes an angle of 0 with the x. So 19 cos 0 as against 19 sine 0. And cos 0 is 1. Sine 0 is 0. The value is the same. Then 22. 22 Newton force has a vertical component and 0 horizontal component. So its vertical component is 0. Its vertical component is 22, but minus. Okay. So this can also be 22 sine 180 and then 22 cos 180. If we look at the angle it makes with the y-axis. 11 Newton, the angle it makes with the x-axis is 30. So 11 cos 30, but negative. Okay, cos 30 is root 3 on 2. So 11 times cos 30. This is minus 9.53. Minus 9.53. I'm approximating it to 2 dp. Then the vertical is also 11 sine 30, but minus. Sine 30 is half. So minus 5.5. Then 16. 16 makes an angle of 45 degrees with the x-axis. So 16 cos 45. And cos 45 is root 2 over 2. So this is 8 root 2 negative 8 times root 2. And this is 11.31. Hey, who is breaking my eardrum? Negative 11.31. Okay. Then the vertical component is also 16 root 2 on 2. The same 16 sine 45. Okay. So 16 sine 45 is also root 2 on 2. So 8 root 3. 8 root 3.
11.0.
Come again. 8 root 3 is 13.86. But that's positive. Please let me see by hand those of you who got this. Who got all components right? If you had all the components right, let me see you. Hey, nobody had it correct. Okay. Okay. All right. So these are the components. Okay, 7.5, 11, the 19 x is, we have 19, y 0, 15, the x is 7.5, y is approximately 13, yes. Then 16, x is minus 11.331. Then the y is, I'm coming, minus 11.3, and then the y is positive. Okay, then the 11, x is minus 9.53, then the y is minus 5. Yes, good. So you look for summation of x's and summation of y. So sum up f of x and then summation of all the y. Help me do this. What is, sum up all the x's for me. Somebody should also sum up all the y's. I'm doing it too, to test your correctness. So open your eyes. Yes, what did we get for summation of all the x's? What did you get for summation of?
5.66.
Okay, so we have 5.66 Newton. Then let's look at summation of all the y's. Yes. What did you make for summation of y's?
Negative 0.65.
Good. The guys are not talking, no guys. Jojo, let me hear your, give me your base. So negative 0.65 Newton. Okay.
Sir,
Yes, Jojo.
and please the y, the fy, the 4 that is 16. I think its y coordinate is wrong.
The 16, it's y.
Yes, sir.
Let me verify. It's supposed to be 11.3. Is that what you got?
Yes.
Let's see.
Yes, 11.31.
Yes, let's verify. 16. Its y must be sine of 45 is equal to fy over 16, and fy is equal to 16 sine 45. Sine 45 is root 2 on 2. So we have 8 root of 2. What is 8 times root 2? Check for me.
It is 11.31.
11.31, and it's a positive. Thank
Yes,
you.
sir.
That is why you must also be involved in what we are doing. Okay. So that if something is not right, you can also point it out. And don't forget, I've been doing this without looking at using calculator sometimes. So it's possible something may go wrong. So let's sum it up again. 12.99 plus 11.31. This minus 22 minus 5.5. And Dodo, what did you make? Minus 3.2.
Minus 3.2. Yes, sir.
So let's correct it. So let's then draw. Let's draw your X and Y axis. Let me change the marker. Our X and Y axis. Now summation f of x is positive. So it is along the positive x. Then summation f of y is negative. We direct it along this. So when you have two vectors in this manner, the resultant would act along the diagonal. This becomes R. Therefore, our resultant can be obtained using Pythagoras theorem. R squared is equal to summation of fx squared plus summation of fy squared. Fx 5.66 squared plus fy 3.2 squared. R therefore is equal to the square root of all this within the brackets. Just give me the value of R. What is R? What's the value of R?
6.5.
So we have 6.5 Newton. Then the direction of the resultant. Let's determine this unknown angle. So help me determine alpha. What did we make for alpha?
29.48 degrees.
Now I have wizard powers. So my teacher.
So let's take it as 29.5 degrees. But since we are taking our angular measurements from the north, we can say that the direction of this is 29 degree, okay, from the east, or when you add 90, this will be the direction of the resultant from the north. Okay. So 29.5 degrees here, if you want to talk about 29.5 degrees, then you must, from the east, you must qualify it where you are taking the measurement of that angle. Then if you want to take it from the north, then you must add 90. Okay. Now, if there is a question on equilibrant, equilibrant has the same magnitude as the resultant, but its direction is opposite. So I want you to help me determine the direction of the equilibrant. The equilibrant must act oppositely like this. So if the resultant is acting downwards, equilibrant must act in the opposite. So what do you think will be the direction of the equilibrant? Are we true? With the direction of the equilibrant? Yes. What have you made for the direction of the equilibrant? Mamiya, what have you had?
$289.
Okay, so this is 29.3, and so this will be 29.5. So when you subtract this from 90, you have the direction of the equilibrant in an anti-clockwise direction. So when you are here, what all that you mean is that you must turn anti-clockwise to get, or if you want to follow conventions, then take it from the north in a clockwise direction. And that also becomes the direction of the equilibrant. Please, is that okay? Okay.
So please can you come again?
What I'm saying is that, you see, if this is 29.5, okay, collect, what is the remaining angle which complements this? That will be 90 minus 29.3. Okay, so what is 90 minus 29.5? Almost 69 point something or 60 point something, right? So what I'm saying is that if you are here, you can also turn that angle in an anti-clockwise direction from the north to get face or get the direction of the equilibrant. Or if you want to follow convention for bearing, move from here in a clockwise direction. But don't forget that will be 270 plus this angle. Okay. Then you must turn from the clockwise from the north through a clockwise direction to face this. So there are two ways of presenting this. It can be that complementary angle anti-clockwise or following the convention. All right. I've sent you another question. Check on the platform. I've sent another question. F1, we have F1 8 Newton at 90, F2 10 Newton at 0, F3 8 root 3, 8 root 2 Newton at 345, F4 6 root 3. I think that part is missing. Let me check the angle and then 6 root 3. Where did I? Okay. So F4 we have 6 root 3 acting at 120. Please 6 root 3. 6 root of 3 Newton at 120 degrees. 6 root 3 acting at 120 degrees. They have 4 coplanar forces acting on a body. Okay. So coplanar forces act along the same plane. And this body has a mass of 6 kilograms. They act on a body, and this body has a mass of 6 kilograms. I find the magnitude and direction of the resultant force. You are to find the magnitude and direction of the resultant force. I, the initial acceleration of the body. So answer, look at the first question, and then I'll come in with the second question. Start work. I'm giving you 10 minutes. Resolve the 4 forces into X and Y component. So we pick F1 and resolve F1 into components. Okay. So let me divide the whole space. So F1.
Sir, please, I can't see your screen.
Is it?
Your camera is off.
Okay, let me change the position. Can you see now?
No,
Can
sir,
you?
like the screen is dark.
Oh, then please rejoin. Is it a general problem to all of you?
No.
Hello, is it a general problem?
No, sir.
So then please rejoin. Okay. So F1
Okay.
is 8 Newton acting at 90. So we have the vertical the X component 090 degrees. So we have F1x as 8 sine 90, and then F1y would be 8 cos 90. Okay, since sine 90 is 1, we have 8, and this is also equal to 0. Then F2 is equal to 10 acting at 0, 0, 0. In bearings, we usually represent the angle in 3 digits. So 10 Newton acting at 0, meaning it makes an angle of 0 degrees with the y. So F2x will be equal to 10 sine 0, and then F2y would also be equal to 10 cos 0. Sine sine 0. Sine 0 is 0. Cos 0 is 1. So these are the components for F2. F3, 8 root 3, root of 2, 8 root of 2 Newton acting at 345 degrees. So F3x would be 8 root of 2 sine 345. And F3y is 8 root of 2 cos 345. Please, what is 8 root 2 times the sine of 345? Confirm for me.
Negative 2.5.
I'm coming. Let me also confirm. Okay. And when you are coming to do this, check if your calculator's angular measurement is on degree. What did you say? Negative what?
2.93.
Okay. So minus 2.93 Newton. Then what is the y component?
10.92.
Again,
10.92.
okay.
10.93.
All right, I'm coming. I'm just verifying. So cos of the same angle. 10.93. Good. Meaning I'm also marking you boots for boots. Then let's look at F4. F4, we have 6. F4 is equal to 6 root of 2 at an angle of 120. So F4x would be 6 root of 2 sine 120, and F4y 6 root of 2 cos 120. Yes, what is 6 root 2 times sine 120?
Please, it's 6 root of 3.
6 root of 3.
I'm coming. I'm just confirming. So wait for me to also.
Mr. J, please, that's not the answer. It's 6 root of 2 there.
It is, you see, sine Sin 120 is equal to sin 60. And that is root 3 on 2.
Sir, the component
Is that the
is
component
6
f?
root of 3.
So this is 6 root of 3.
Okay. Root of 3, eh? Let me check. Okay, thank you. It's root of 3. You're also marking me boot for boot. That's good. So 6 root of 3, okay, times sine of 120. This is equal to, what did you get for 6 root 3 times sine 120?
9.
9. Good. Then what did you also make for the cos of it?
Negative 5.2.
Negative 5.196.
Okay.
Minus 5.20.
Minus 5 points. Okay. 20. I think minus 5.20 Newton. All right. Thank you. So this is, I think this is the difficult part. So after expressing all forces into components, then you come to summation Fx, which is F1x plus F2x plus F3x, if you want to go systematic, plus F4x. F1x, we had 8. F2x is 0. F3x, we had minus 2.93. Then F4x is 9. Sum this up for me. 17 minus 2.93. What did you get?
14.072. 14.072.
Okay. So 14.07 Newton. Then summation Fy. F1y plus F2y plus F3y plus F4y. F1y is 0. F2y, we had 10. F3y, we have 10.93. F4y, we had minus 5.20. Put everything together, we have 20.93 minus 5.20. What's your answer? What's your answer?
15.73.
So this is 15.73 Newton. Okay.
15.7.
All right. Let's then draw. They are all positive. So
15.7.
okay. Thank you. So summation f of x is positive, which is 14.07. Summation f of y is also positive, which is 15.73, implying that the resultant would act along the diagonal here. Therefore, R squared would be equal to 14.07 squared plus 15.73 squared. What is R? What is R?
Sir,
Hello?
please can you come again from the drawing part?
I'm coming in. Okay, what I'm saying is that what I'm saying that you see, when you found summation f of x, we had positive 14.07. Summation f of y, we are having positive 15.73. So you draw the Cartesian plane, your x and y axis, and put these figures or values of summation x and y along the Cartesian plane. So by getting positive f of x, it means that summation f of x will lie along the positive x because its value is positive. If it is negative, it will act along the negative f of the x-axis. Then summation f of y, we had positive 15.73, meaning its direction must be put along the positive y-axis, and that will help us to get the direction of the resultant. Are you okay?
Yes, sir.
All right. So this is equal to, R will be equal to, yes, when you square x and y, what will be the value? What did you get for some the sum of that? Squaring this plus the square of that, what will you get?
445.39.
Okay, so we have 445 points.
Point
Let's
40.
make 40. Okay. Square root. So square root of this, of my answer, this is equal to 21.1 Newton. So that's the resultant force. So the resultant force is always that single force, okay, which is equivalent to the combined effect of a number of forces, meaning F1, F2, F3 to F4 acting at different angle. What they combined can do, only this will do the same thing. So the direction, let's find the angle theta. Of course, tan, if we take the tan of that angle, summation f of y over summation f of x. Fy is 14.07 over fx. Fx is, sorry, Fy is 15.73. 15.73 over fx, which is 14.07. So do that and then give me the value of theta. What is the value of theta?
48.19 degrees. 48.2 degrees.
Okay, let me confirm. Okay, so 48.2 degree. Thank you. 48.2 degree. That is from east, or 90 minus the answer, which is 41.8 degree from the north. So this is 48.2 degree from the east, or 41.8 degree from the north. Please, are we okay?
Yes,
Are we
sir.
okay? All right. The next question is about the initial acceleration. Okay. Acceleration is changing velocity with respect to time. And Newton's second law says that a body would accelerate when there is change, when there is an external force acting on the body. So whenever there is external force or a resultant force acting on a body would accelerate. So once we have calculated for R and it is not zero, it means there is a resultant force acting on the body and the body must accelerate. And so, even though you haven't done Newton's law, dynamics, but we will apply it here. So, whenever there is a net force or a resultant force, a body must accelerate. The value of the acceleration is directly proportional to the value of the resultant force. So, Newton is saying that F is equal to mass times acceleration. I just said F, which is the resultant force, is directly proportional to acceleration. And whenever you have this proportionality, when you introduce an equal to sign, there is a constant of proportionality. The constant of proportionality is the constant mass of the body, which doesn't change from place to place. So M is, the constant is the mass. So when I'm looking for acceleration, A is equal to F over M. What is F? F is the resultant force. And here we got 21.1 as the resultant force. So 21.1 divided by the mass of the body. What were we given as the mass of the body?
6.
So 6 kilogram. Good. So 6 kilogram. So 21 divided by 21.1 divided by 6.
3.52.
Okay. So this is 3.52. What is the SI unit? What's the SI unit?
Mass per second squared.
Meter.
Oh, sorry, meter.
Okay, so meter,
Meter per second.
there's the acceleration of the body when this number of forces act on it. Okay, so it isn't so difficult, but you just would have to understand and apply. All right, colleagues, this is where I'll end today's show. In fact, it hasn't been easy. I mean, teaching you today because I haven't been so well. But since we are also